Very good morning to all of you. My name is Desna James, and I take great pleasure in welcoming all of you to the webinar on modern approaches in building secure web applications, conducted by Viva Web Technology, part of the Department of Computer Science at Vimla College, Thrissur. I would like to welcome our respected principal, Dr. Sister Mia Jose, our vice principals, Dr. Sister Namita and Dr. Minimol K. Jose, our Viva coordinator, Dr. Prima Rose, in their absence. I'd also like to welcome our resource person for the day, Mr. Sanoop Thomas, the head of our department, Sister Annie Davis, all our staff members, and all of you, our distinguished guests. It is my great privilege to introduce you our resource person, Mr. Sanoop Thomas. With over 10 years of experience in information security, he is the founding organizer of Beside Singapore and the author and maintainer of the Halcyon IDE project. He has immense experience in organizing events and workshops to spread security awareness, and we couldn't have asked for a better speaker for this event. Thank you for attending, sir. Before handing over to our speaker, please allow me to mention some guidelines for this event. The webinar will be recorded and the recording will be made available to you. We will have a Q&A session at the end of the webinar. Towards the end, you may ask your queries in the chat window and they will be addressed. We request you to kindly mute your audio and turn off your video so that we can avoid any background disturbances. After the webinar, you will be receiving a feedback form to rate the quality of the session. Once you submit your feedback, you will be receiving an e-certificate for participation. We have certain restrictions set by WebEx in terms of meeting duration, so there is a chance that the meeting will end abruptly after 50 minutes. In case that happens, please don't panic. We will be sending out a second meeting link right away, and you can rejoin the meeting by clicking that link. So please cooperate with us, and we hope you have a very productive session ahead. Please allow me to hand over to our speaker, Mr. Sanoop now. Thank you.
Thanks, Desna. I hope my screen will be visible for everyone.
Yes, sir, it's loading.
Awesome. A very warm welcome. Good morning, everyone, and thanks for taking time to join this session. Today, what we are going to discuss about is modern approaches in building secure web application. This is going to be like more of a security insight and also secure coding practices, something that we, as an academics, we are not really taught by campuses or the universities, but something that we should be aware about. Quick background on myself. Yeah, I mean, as Jasna mentioned, I'll keep it short here. I'm into InfoSec for about 10 years plus, dealing with application security, infrastructure security, and different fields in information security domains. I've done my computer science and masters in computer applications back in I can't recall the year, but pretty much in Kerala and Tamil Nadu. That's pretty much it. My academic qualifications, and I've done some certification that are related to security. I'm maintaining few projects that's open source and more of a community awareness. And feel free to check that if you get time. Also organizing international hacker conference that happens every annually in Singapore. So we get participants from like different countries and different regions, different locations. They come together one day in every year and discuss about different hacks and different security issues they have researched over the course of a year. So I go with that handle on my GitHub projects and my social media. So that's pretty much it about me. Before we start, we probably need to understand why we have these sessions. Today, the world we are living or the world that we are actually moving forward is very heavily dependent on code. Someone somewhere have actually written a piece of code and that's running on our daily life devices. Let that be starting from your refrigerators or microwave ovens or your laptops or your mobile phones, TVs, and whatnot. All of these devices
Excuse me,
actually
sir. I think your screen is still blank.
have. Sorry, am I breaking? Oh, really?
Yeah,
Um, let me start. Let me reshare it again and see if it works.
sure, sure.
Is it any better?
Um, Not yet. I mean, your screen is shared, but it is blank.
How about now? Is it visible now?
No, not yet.
Presenter view? Or, is it still blank or able to see my slides? Strange. Okay, are you able to see my screen now?
I can see it now, yeah.
Just making it as in a presentation mode. Let's see if it works.
Yep, works.
Awesome. Thanks, Isna.
Thank you.
So we were discussing about our daily life runs on code and something that as computer science students or someone who actually working on programming languages should be aware about. These are heavily dependent on what we are daily doing. With that, our agenda is to understand what happens to these code if someone actually someone write these codes in a badly manner or with a buggy code, and what happens to those code snippets. And we'll understand where we are today, and what was the programming culture traditionally, and what's the modern web applications have been developed. And we'll basically see how this is fundamentally happen to be wrong. We are trained in a specific way, but professionally we are coding in a slightly different ways, and we'll see that gap. And I will also share some resources to fill that gap. And with that, we'll also discuss about some of the application security threat landscape, because before we start protecting on attacks, we need to know how these attacks are actually happening. Uh, then we'll share some of the best practices and some standards that we can follow that will make things easier as the learning path progresses. So some of the historical details, right? I have collected this information from just in 2020s and what happens this year starting from January. Um, these are some of the attacks or breaches that happened on financial or banking institutions starting from 2020, and these are um, selectively collected some specific banks or Google Pay abuse cases, or some of the credit card breaches and things like that. So these are like just from January onwards. We are just 6 months more to go this year, and there will definitely more such incident happens. All of these somewhere or other connected to a programmer's written bad code. Now, if someone actually writes such bad codes, what effectively that implies. So, few examples here, like Marriott. Some of you might already know this group. They are a group of hotels running across country or globally, and they have announced a breach in the month of March and early this year, and that cost about 5.2 million people information was leaked out. So an attacker was able to get access to these 5.2 million people information. That includes their name, their address, their passport information, their booking dates, including the booking information, meaning payment information. So that includes both their personally identifiable information. We can basically trace down who is that person, and also their credit card informations or their payment informations. Now, because they breached was affecting their personal information and payment information, they were fined about $123 million, and that's a huge fine for a company to bear just because a developer actually written a bad code. Another example, this is explicitly I've taken from 2018, just to showcase that how largely this can affect. This is British Airway. Their payment informations or their booking information from specifically August 21 to September 5 was leaked out. So that someone was able to funnel out these 3,80,000 booking information. That includes again, when you book a flight, you typically add your passport informations, your personal informations, your payment informations, and these informations were actually costing them about 229 million fine. This was so far the largest fine imposed to an organization because of a data breach. And we'll come to this specific case, the specific airline booking case, what explicitly caused that bug, and that's not a very serious or very critical bug. I mean, or rather, I would say it's not a very complex bug. It's a pretty simple and straightforward bug, which could have been detected much early stage, but they were not able to do that. Now, going back, we are discussing about things that's happening maybe outside India. Let's come back to India and see what happened there. Last Saturday, I don't know if anyone actually noticed it. Last Saturday, a group claimed hackers, and they were able to access the COVID patient informations of Delhi government. And surprisingly, this happened to be some hacker dudes from Kerala. They claim themselves as Kerala cyber warriors. And these are some of the screenshots they've actually taken as an evidence and then posted on their Facebook page and say that, hey, we got access to Delhi patient information that basically have all the records of personal information, contact numbers, their age groups, their addresses, and whether their test results were done to be positive or not, and also have an options to go ahead and edit them. And that's crazy because these are very sensitive informations, and they were able to manipulate that with no specific legal authority to do that. They were able to also add new patient information. I mean, you can actually add new positive information. This is more of a national security issue because the numbers are getting manipulated because of a data breach. And we don't know where this case actually goes, and pretty much under investigation now. So we know that all these applications or all these programs that we are actually coded is causing either a financial problems or a national security issue. Now, why do we develop such buggy codes? Because the traditional way of developing software doesn't have security implanted in it. So you might have seen this diagram pretty frequently in your curriculum. This is a traditional waterfall model, and the problem in this traditional waterfall model, it's very plan driven. So you design you plan something that this is the feature that you want to build, and then you go through like phase by phases. It takes weeks or months in some cases, and by the time it reaches the production, maybe that feature is no longer needed for a consumer. So it's not really a consumer focused um, approach for developing application. And all of these things actually driven by the planning phase, meaning the project management has more control, and the dev leads or the coders will have less control in traditional approach. Whatever project management decides to build is ultimately that's what exactly developers are actually going to build. It's not very fit into the current modern trend, because if you see the applications, the frequency of application that's getting shipped into production is not uh, slow. It's rather very fast. You'll see the features getting updated super quick. Maybe in within a week you will see updates. Like you're just analyze how many times you'll see a update on your mobile applications, and you'll have to go and update those, and that gives you like new features. Happens pretty much every week. So that's the options today that's happening, but traditional approach is not that much customizable. By the time it is in the production environment, accessible to customers, it's no longer customizable. But currently, the web applications or any software application development is more moving towards agile. I'm assuming you might have heard about this term or referred to this approach sometimes in your studies. Um, and this gives more control to everyone, not just the program managers. It also gives controls to the entire team, including the developers, to build and decide customized features according to the customer's need. And it's very focused on customers, and that's why we see like new features are keeping updated. Like sometimes you'll see there is a social media post on a website saying that, hey, we probably need to have an extra features, and within next weeks or within 2 weeks, and you will see an updates that actually pushing that features, and that's getting like more feedback driven rather than planning driven. So that whole cycle is rather call it as sprint, and it's like a repeated activity. And it's definitely more customizable because developers will have more control there. Now we'll see the threat landscape here. Um, there are different levels where an attack can happen. The bugs or a bad code happens where you write code, like you will develop code, and that code itself is insecure. It's not securely developed. And there are bugs in the libraries that you're using, or the frameworks that you choose to develop a platform, or any external dependencies that you're using. It doesn't have your control because it's developed by somebody else. Just using it, you are a consumer of that dependencies or that framework, and you don't even know whether those codes are secured. So the bugs can be relying on that. All the bugs can also be running on the server level itself, or these days a lot of applications are using containers. So it will be running on that. So it's not on it's not on the dependency, so it's not on the code that you developed, but it's where the code actually runs. um, and most importantly, these bugs are keep evolving. The program that I have written probably like 10 years back is no longer secured at all at this time, because the new bugs are evolving. So we'll also have to keep a track of like what code are we writing, what dependencies are we using, where are we running this code, and also keep track of these technologies. Make sure that there is no new bugs are releasing on these all these three mentioned parameters. Now let's split these into like each sections and see what type of bugs that we can find in each sections, in your code, in your dependencies, in the containers or in the servers, and then how do we tackle it. So the reason why bugs happens on the code itself, like the way we write, is because culturally we are not trained to write secure code. We are focused on developing code based on functionality or user friendliness, right? So if we see it like, hey, you need to create a login page, and you pretty much create a username and password, and then connect to database, access it, authenticate it, validate it. That's it. But we are not really making sure that how many people actually going to use it and what are the possible attack surface there. And that stage happens at very later part. Yeah, sometimes even after shipping into production, we'll see that something is broken because of security, and then we start digging in. And that's kind of like, you already built something and now you started breaking things, and that might requires a lot of design changes also. So it's not really cost effective in the traditional approach. So, and a big gap happens where the developers are not well aware about the attack surface. So to tell a developers or a coder, hey, you need to fix a lot of attack surfaces, you need to fix a lot of security bugs. A developer has no clue about what is these attacks. And they don't have a visibility on how these attacks actually happens. So that's a big gap. And sometimes the coding practices or the frameworks that we are choosing is not facilitating any security practices. So some of the examples here, example frameworks here that can be used for, they provide like security by design. So they are built to completely eradicate a specific set of vulnerabilities. We'll explain a bit details with code snippets in later, but I'll just give you a brief summary here. ORM is a technology used by a lot of modern programming languages like Django's or Ruby on Rails, and a lot of other frameworks. So it's basically like an object relationship, uh, object reference mapping. Sorry. The idea is to not have dynamic statements in the query, but it allows you to um, you know store values or uh, store user values into an objects rather than just dynamic values. So in simple, we'll explain this in details, and you'll get more understanding how this works. But in simple, you might have heard about a specific group of vulnerabilities. If not, just Google search about it. It's called SQL injections. Frameworks that are using ORM technologies will not have a SQL injection vulnerabilities. That's the frameworks providing that kind of a security features by design. So by utilizing a coding practices that uses ORM, you're completely eradicating a group of vulnerabilities, like a whole classes of SQL injections are going to be eradicated. And there is another set of vulnerabilities called, like, let's say, cross-site scripting. Again, just search about it. It's pretty cool bug. And there is another terminology used by frameworks called safe rendering. And safe rendering basically eradicate a group of cross-site scripting vulnerabilities. And there are frameworks that allows you to set security as middleware. So it's kind of like gatekeepers. Or if you're using authentications, using OAuth as a centralized SSO is going to be eradicating a lot of authentication bug, right? So these are some basic examples. I know it might be a lot of high level terminologies now, but don't mind. Just at least you have the terms to search forward, so you can just go ahead and then research about it, or study about it, how these things actually works in secure development practice. So here are some of the examples. I wanted you to take some time, maybe a couple of minutes, and read this. This is a simple Java applications and pretty much familiar language, I hope, and see what possibly will be wrong here, right? So if those who don't have an understanding about Java, so just let me summarize it. Just a simple class have a main function. It's like the first class, or the main class, you could say, and it has a username and two passwords. And username accept just enter username. Just it's a console read line option. It just takes the username, and it also takes two passwords, just two different passwords. Um, and what could possibly be wrong here? So there are two things that's visibly very wrong. One is in the statement itself, like the console statement. So system.console is a function that allows you to enter or accept values from the command prompt. So if you're running it as a command prompt um, binary compiled file, and you can basically accept inputs in it. So read line will basically show the results on the screen. So if you're typing a passwords on the command prompt, you will be able to see the passwords in clear text in the prompt. So visibly, there is a difference, because read password will understand the value that you are entering into that console is not really a string, but it's rather considered as a password value. So it doesn't show that visibly on the command prompt. So it's a pretty evident visible differences in that. But um, and that's on the user experience side. Like, of course, if you want to type a passwords, and you imagine that you are sitting with your friends and then logging into Gmail, and Gmail password field is actually showing the passwords instead of star star star. That's going to be embarrassing, because you'll see the you'll know your friends, or the people who are actually behind your shoulders can view that password in clear text. That's not a better user experience. So read line and read password has that difference. But one more difference that's more interesting here is the way it stores those passwords as an object. There are two ways this program is storing it. One, the passwords are stored in a string object, and the other one is password is stored as a character sequence or char array. The difference is in this: the string objects are known as immutable objects. So let me explain what is immutable here. When you reserve a string object in the program memory space, and that memory space is not uh, removed or cleaned by default unless there is a garbage collector is explicitly clearing it. What I'm referring by that, if you're adding string password one equal to something and then you're assigning a different value, the older value is possibly going to be somewhere else in the memory because there is no overwriting happening because these are immutable space. So in short, immutable means the values cannot be changed. It's going to be preserved in the memory, right? But the character sequence is something that we can explicitly overwrite it. So you can basically clean it or null it out, meaning you can take an whole array and say that the whole array value is going to be like null after you receive the passwords, use the password to authenticate the users, and then you can nullify it. So what are we trying to explain here is one is the string objects gives you a longer lifetime of sensitive information in the program memory. But in the second case, whereas the character sequence, you have an explicit control when you want to accept that value in the memory and when you want to clean it up. So the lifetime of a sensitive password information in character sequence is controlled by the developers, and that's a choice that developer want to make when writing a program. So it's a very simple example, not related to website or web applications, but the same principle applies to a web application as well. When you're writing, you choose to write convenient code practices rather than secured way. So here is another example, right? This is also in Java. Uh, a simple program statement, basically to query a database where select star from users where id equal to some parameters, and you basically execute it. So it's a typical web application database connectivity. Um, and the problem happens in this particular statement. The way a program or the Java code is creating those SQL statements. So if you see the SQL statement is actually written as string. So because Java doesn't understand SQL queries, so the easiest way for Java to write a SQL query is to write it in a string and then pass it to a connection string statements and to execute it. So it goes to the database and then execute it. But look at that statement itself. Like it's a select star from users where ID equal to parameters as string because there is a double quotes or there is a single quotes over parameters. But what happens if someone giving that parameters as this pattern? So the pattern is like just one because we don't know about what's the ID of users. And then we are adding a character A equal to A, but not ending that codes. So what happens here is this code is already here and that will be mapping here. And so that means the ID equal to one. But if the ID is not equal to one, doesn't matter because we have an OR condition. And then there is a string A equal to A. We can just give it as any values like true equal to true, B equal to B, whatnot. We can give all of that. But that ideally going to create an SQL query like this. Now, this SQL queries will be very malicious because this means we are not extracting users of ID, but we are technically extracting all user values wherever this condition fits, meaning ID equal to 1 or A equal to A, meaning that's going to be a universal true condition. And this is classic SQL injection example. This is the easiest way we can actually create database queries in Java. But there is another variation how you can write the same query. which is using something called prepared statement. So prepared statement is a coding practice where you can basically eradicate SQL injections. But because here also you will see the select statement, but you will see an ID equal to question mark, and then you will see a statement set string one, meaning the first question mark is parameter. So this will not have a SQL injection because this the prepared statement set string function um, takes this value as a complete literal. So if you give this value here, it's going to actually search in the users table for an ID that's equal to the entire string, because the whole string is going to be considered as a literal instead of a string escape characters. So it's a very simple example how you eradicate SQL injections in Java program. Um, Now, an example in, let's say, modern programming languages like Django. So Django is a web application language for Python. So it's a design for a lot of security by default or security by standard principle in mind. So here is how the cross-site scripting vulnerabilities are being protected on Java application. Sorry, on Django applications. And again, if those who don't know about what is cross-site scripting, just go and search about it. It's basically a browser-based attacks. You can write malicious JavaScript on the user browsers, and you can get activities on user browsers, like adding an extension. Sometimes you will visit a website and there an additional pop-up happens and say that, hey, you have a virus affected. So these are like executed by JavaScripts. So here is a simple examples how uh, Django actually protects it from cross-site scripting. If you see here, these are like two request, first name and last name, and then we are adding into a like context variable, and this context variable is going to be added into a home HTML file. This is a home HTML file. It's a simple HTML file here, and here is an example of how home.html might look like. So the first name is going to be rendered. So the double curly brackets, meaning in Django template, means you are printing it back to the browser or in the HTML context. So by default, when you're printing any variable to a template or an HTML template using Django, it's going to be escaping all those JavaScript. So if you're adding a script tag, it's not going to be rendered here, meaning cross-site scripting will not happen here. But at the same time, if you use this statement, the below statement as first name and save, you're saying that this value is safe, so render it. So the malicious script that you're adding as first name is going to be rendered here, meaning this section of the code will be vulnerable for cross-site scripting, whereas this will not be vulnerable for cross-site scripting. So that's the difference. This is a choice that developers actually need to make. Again, as I mentioned, when you choose a frameworks or a technologies that is driven by security by default or security by design principles, you will see by default it is this. To make a bug, you probably need to explicitly give this extra tag. So just a simple example how you can see that comparison. Now, we have discussed about SQL injection in Java and how you can use prepared statement protections in Java, right? The major problems what you could see on those Java statements or Java examples, because the Java code block is writing SQL query within Java block as string, and that's the main problem. So what Django is giving is an option to remove that. So in Django, database is known as like models. So you will have a users model, which means user table. For instance, I have first name and last name. This is how you basically build a tables in Django. And typical query will be like this. So this is fairly similar to what we have actually seen in Java. If you see cursor is the connection string, similar like in Java, what we have connection string there. And you have an execute statement and you have insert into users and first name, last name values. And this is typical SQL query. But here the SQL query is dynamically created because param1 and param2 will be replaced by these string replacer or string tag. And this will definitely have SQL injection because this is similar like what we did in Java code block, right? But this is not the default way of how you write database connections or database queries in Java. This is something that we can have an option to choose it. But the ideal or default way is what I've explained earlier called ORM, object relational mapping. And you will see the code block doesn't have a SQL query. So you will not see the SQL query being executed here, but you will actually see uh, the SQL, instead of SQL queries, you will see the first name and last name is being created as an object and you save it. So this will create a SQL query in the background and then write it because you don't have an option to like escape it. Uh, Let me make it into presentation mode. So we discussed about this ORM case. We are all tracking on it. So there are a few resources similar like SQL injections or cross scripting. There are a lot more attack surfaces, and definitely like 1 hour or 2 hour sessions or maybe 1 day sessions are probably not enough to cover all of that, and it requires like a more detailed or deep knowledge or deep learning here. But so I'll give you a few resources here, and that's going to be like really useful. There are open web application security projects called like OWASP has released a top 10, and they keep updating this in every 3 years once. The idea is to pick up top 10 known highly exploited or largely exploited vulnerabilities, and then they basically list them out in the order of their ranking. So it's a good way to actually learn what trending or what are the top 10 vulnerabilities that industry is actually looking forward to. People who are in the security industry also use that as a benchmark or a standard when testing an application from security aspects or coding an application from secure coding aspects. They also have a secure coding practices guidelines, and this basically teach you how to do an input validations, how to perform a regex in a secured way, or pattern matching in a secured way. How do you create an authenticated request in a secured way? And for all those aspects, all those top 10 vulnerabilities, what are the counter coding or secure coding practices? There is a very detailed reference guide there. And these are like free materials, by the way. So it's an open community project. Uh, those who are interested in like in knowing the attack surface from a practical perspective, like how do you actually perform SQL injections or cross scripting or whatnot, all the different types of attacks. There is a website called Portswigger Web Security Academy. This is again free. You can just go online, you know, just sign up yourself and then access into different labs. They have scenarios like SQL injections on a specific application and see what you can do with those applications. You can basically practice it. So don't go ahead and practice on public websites. That's not really legal. So I don't want you to get caught. But you can actually use these kind of legitimate resources to practice and learn about. And there are tons of people actually learning this currently. Um, uh, People who are in programming interested areas, like those who wanted to be those who are good in programming and want to upskill themselves as secure coders. There is a code bashing free trainings, and that gives you a SQL injection vulnerable code and then ask you to fix it, and then basically have a small tips and hints, where is the bug and how to fix it. So they give you like different code blocks, and you can actually go ahead and fix them. And similar to that, Code Warrior is another security company, and they're specialized in application security and secure code practices. They have this portal, and it's more like a online game. They kind of completely gamified the source code or secure code practices. So you'll see a lot of different people joining all over the world and trying to protect a particular piece of code, and they write different code snippets. So you'll see other people ranking. So it's more of like a fun online game. So you can experiment with that. So these are like some of the resources you can take a note on. Now we discussed about the bugs that happens in the code that you write, and you have resources how to fix them or how to learn how writing secure code or practicing attack surfaces or attack patterns as well. Now, the second topic what we discussed was the bugs that you don't have control on. You're not owning those piece of code because they are dependencies, they are libraries that you used on your application, existing libraries or existing frameworks, And how do you find security issues on that? How do you ensure that these dependencies or external libraries are securely coded? And there are several ways of it. This is just an example, such kind of bugs and what it costs. And it's the same example as I mentioned about British Airways, right? The company that got penalized the highest in the history of security breaches. So they were using a third-party library called Modernizer and a specific version 2.6.2. It's a JavaScript library, so you could see that online. And they haven't updated that. According to their developers, they haven't updated that library. So this was a screenshot of their um, the library's headers, and that actually shows that this code was last modified on December 2012, and since then there wasn't any modification. But when the company who is basically doing the breach investigation of British Airways uh, noticed that this code was somehow modified on 21st August 2018, but the version remains same. It's still 2.6.2. Same JavaScript, but it seems like there is a difference in this code. And so they investigated what exactly is the code. So, excuse me. So they pulled out the JavaScript code, identified like what exactly is the difference, and the red highlighted section is the extra code. So you will see, excuse me. So you will see the um, a specific code block is there. This is an appended one from 2018 modified piece of code. So this may be a little blurry or very small for you to view it. So here is the actual code that caused the whole problem. And you could notice this just a 22 line of JavaScript code embedded or rather appended into the existing third-party library by accidentally or someone actually injected it. So we don't know about that. But let's understand what the code does. So it's a JavaScript code that runs on the same page, and it identify that, and it rather like binds a mouse up and touch end, these two events, to the submit button. So you have a web page and they have a submit button, right? And they will bind these two events there: mouse up, touch event. And what this function does, they also pull out the payment form. So where you basically enter the credit card informations, your billing address, your um, ticketing informations and whatnot. So they will basically pull out the payment informations into a JSON value, and they send it to a URL called baways.com gateway app data processing slash API as a JSON object. So um, interestingly, what they're doing is they are just pulling the submit button, adding an event on the submit button whenever the mouse up or a touch event happens. So someone actually go ahead and like make the payment, fill up the payment form and click the submit button. They will pull out the submit form itself, like the whole value of submit form, change into a JSON object, and then send it to an API call. And these API calls are definitely a third-party API calls, so probably controlled by the attackers or the hackers. And this is how they are basically funneling all the payment information from a specific date, like to 21st August till September. So imagine this 22 line of code is the actual culprit that cost them 200 plus $1 million fine. That becomes like the largest fine in the history of data breach. So it's that serious. A small line of code can actually cause millions and billions of dollars issues. So to identify such cases, what we can do, like how do we ensure that these dependencies are secure, dependency libraries are secured? How do we ensure the safety of that? So one is the official announcement of it. Like most of the third-party libraries or the dependencies or the frameworks that you're using, if you're using Java, maybe Spring or Hibernate or Django, so you'll see their security announcement. So if you're a developers, make sure that the technology that you're following or writing code, you subscribe their security announcement. These are pretty much free subscriptions, anyways. So it just notifies you if a new security bug was released and they fixed it. So you are aware about there is a new fix happened on the language or the frameworks that you've used. And there is also like a public security announcement. So these are like public disclosures, or what they do is they collect open source, all open source projects, and most of these open source projects are maybe hosted on GitHub or GitLab. So they will collect all these informations and then create a database of vulnerability disclosures. And this is interesting because you can go there, search for the library that you're using, maybe Modernizer, and search for it, and then see which version has which vulnerability. That's also an effective way to track or keep tracking the vulnerability that exists in third-party libraries, because we can't read those codes, and we even if we read that code, probably it takes a lot of time to like read those codes and analyze it from security perspectives. But these services or free services actually does it for you. Um, for the lot of website or the resource files actually follow a principle of file integrity monitor. So the time you coded something, or you added a library into your package or to your applications, you basically create a signed library, or rather create a checksums or a hash value, and then make sure that the file doesn't change. Because if the file changes, so the hash value fails. So that makes sure that your existing libraries are not tampered by accident. You also have an option called a dependency scanner. This is a free project from OWASP. There are several free projects or open source projects, and dependency check is one of them. The main objective of dependency check is to get the library and then scan against known vulnerabilities. So instead of you are reading those code and understanding about the security aspects, these open source scanners will does the job for you. So you can utilize it, the program that you're writing for. And also make sure that when you see a new updated version of the library or dependencies that you're using, just see what is being updated. Like this is not just for the library update, but in generally life, keep it as a practice. When you see an update of WhatsApp or any other applications on your phones, that actually tells you like what is being updated. We rarely take an due care to read what is that update. What we just need that update to be done. So you just go ahead and then update it. That's a good practice to have. So to keep a track of what is being updated, and what explicit component is being updated, and same for the frameworks that you're using or the language that you're using. Sometimes you'll see like, hey, Java is being updated from 2.0 to 3.0, and we don't know what's the migration, so we just rely on the updated. It's not always about keeping the latest updated one, but it's securely updated one, right? Some of the updates are just functional level or UI, or the non-security update. So you're not very relying on that, because when you change the dependency, there are also possibilities that the applications might also fail. So you probably need to understand, um, not just updating is the safe way, but also make sure that security updates are more important. And now, where the code runs, bugs were happens to be maybe some of the applications have a proper data centers, or some of them actually runs on cloud. How do you secure those premises, and what services or what cloud accounts that you're using? Make sure that nobody have access to those cloud accounts, but because you're only exposing maybe web application there. But the web application itself, like the web servers or the application server, the databases, the security of that, make sure that they are patched and they don't have vulnerabilities. There is network related or infra related scanners, and these are Nmap is a free scan, by the way, so you can basically go ahead and then run your servers. Don't run it on your online. Let's say don't run it for nmappfacebook.com. That's illegal, or they could actually get issues with that. But the servers that you are hosted, you're owned on, maybe you can do it on your experimental laptops and host an Apache servers and run Nmap on it and see what it throws back. Nessus have a free version. It's not only Nessus. There are several infrastructure vulnerability scanners available, so you can choose to do that. So at least do like one scans, or at least choose like one tool to scan regularly on the infrastructure that you're maintaining. And also like these infrastructure will have application server, Apache servers, database servers, MySQLs and whatnot. Make sure that they are also updated, they're also security updated. um, and once you take care of all those aspects, right? You did your secure code practices learning, you started writing secure codes for your applications, you analyze the third party code running on your applications. You verified that with the dependency check. Um, but how do you make sure that you keep track of it? You keep track of the future bugs that might happen on those libraries or those platforms. So this is some of the vulnerability databases where they disclose uh, evolving vulnerabilities, right? The new version of Django may also have security vulnerability. So how do we know that? And some of the libraries that we have used may not have a security announcement or security um, forum, right? So you probably can visit these websites and they will track of it on a central basis. So you will pretty much these entries will be like replicated. You will see similar results of Explorer DB in VulnDB and NVD as well, but you can choose which one to follow for. So I pretty much jump from one to another's on and off depending on cases. But it's a good practice to have. So with that, so let me conclude it by a few aspects here, right? What we are trying to achieve by this presentation. Um, Security code practices are not being practiced from the beginning, but that's something that we should be practiced from the beginning, because it's the way you're trained how to code is not the way how professionals are actually coding, because they are now very concerned about security code practices, because it's not easy to have a data breach. uh, these data breaches actually cost money. So you be a very awesome developers company may not be very interested as long as you don't have a security knowledge on it, or how do you actually code secure applications. So and that's also like keeping yourself as an outnumbered candidate when someone wants to hire you, because you know that hey, you can actually develop an application, but you also have knowledge in building secure application. That's a bonus point for the companies, because they don't want to invest on training you, educating you on that. It's a cultural difference. And it's also important to understand, as a developer, we are less concerned about what information are you handling on the applications. Like we don't really care about whether the users are going to enter, let's say, PAN informations or personal informations there, or credit card informations. We're rather concerned about the user experience, but something that we should be care about, because the fines against those informations are also crazy. So you have seen those examples already. Um, and when building applications, the keep it as a practice or keep it as a learning method to understand the application attack surface. The reason, because if you can tackle those problems at the early stage of development, you don't spend more money after your code being deployed into production. Because once it goes to productions, and then taking it back, securely coding it is going to be like a lot of effort. So the earlier you adopt secure coding practices, the better for the company, the better for the applications in general. And as you probably know it already, like hackers are doing very smart. They are evolving. They are upskilling their own tricks. They are having their own tools. They are building their own strategies to break into applications time to time. We should be stuck. So developers should be also catching up with smart moves, smart secure coding practices, scannings, and whatnot. So I hope that gives you better information on how things works in the application development on secure code practices on the modern web technologies, the modern application security technologies. I'll conclude it now. If you have any questions or have any security related discussions that you want to have, I'm open to have receive emails and answer your questions. We can also open it up for QA sessions if you have any questions to ask me.
Thank you, sir, for that very informative session. We'll now move on to the Q&A session. So if you have any questions, please type them in the chat window and we can address them. Okay, so we have one question. Which article can we identify current attack status on different web applications and social media sites?
Sorry, can you repeat the question, or is it in the chat?
It is in the chat window. It asks, how can we identify the current attack status of different web applications and social media sites?
On social media sites, that's interesting.
Yes.
Um, there are several, and most of the social medias, or whether it is like Facebook, Twitter's, Instagram, WhatsApp. Well, WhatsApp is not really social medias, but considering we have a lot more groups than needed, could call it as social media as well. Um, so these programs usually have open security research programs. So what I meant by that, they have they basically call it as like bug bounties. They open it up on their Facebook page. If you go to, let's say, facebook.com/white hat, you will see the people who have actually reported bugs into it, and they will kind of reward you. They will give you like pretty good money if the bugs are very valid and critical. um, the good way to approach it, there are several attack surfaces on social media because it's very prone to uh, tricking users, because you can actually send a person a link and on social medias, and they can just go ahead and then click there, and maybe there is an account takeover happens because the link was malicious. That's very common one, and you might have seen people are giving you invites to an app. So like Facebook itself may not have, may not have like very publicly known vulnerabilities, or rather like very serious bugs, but the apps that used in Facebook, they are created by some third parties, or some other companies might have created those apps, so like games or things like that. They may have bugs, so you probably have issues with that. I'm not saying that Facebook is secured, and no program is secured as long as they are deployed on productions and someone has access to it. So especially on online. To understand about their bug bounty programs, just search on their website itself. They have open bug bounty programs where anyone, not necessarily to be a security professional, if you're a developer, if you're just curious about how things works, you are allowed to go ahead and hack facebook.com or twitter.com, as long as you follow the guidelines. So just read about the guidelines, because it's also concerning. Sometimes the hackers, or rather security researchers, will go after social media platforms. They do it beyond their rules, meaning they try to like get access to other people account, and they claim that, hey, was a security research. And Facebook, or any social media programs, or any website for that matter, is not going to appreciate it. So read their bug bounty guidelines. You will know that what's in the scope, what you can actually do with the platform, and how do you report it. And that's a good way to learn it, because these are like live applications. So the I think the time you spend on those platforms are actually going to be a good learning.
Okay, thank you, sir. We have another question. When we compare modern approaches to the traditional ones, which can we say is more accurate, or how much accuracy do both have?
Modern approaches. I couldn't get the question. Can you repeat that, please?
The question says, when we compare the modern development approaches to the traditional models, which can we say is more accurate?
Which one? It's not about accuracy. It's more what's fitting, right? Because traditional approach is also accurate. It wasn't wrong, but it's wrong for the time now we are living in. Um, we can't, or any software development or application companies, or product development companies cannot design a product for 1 year for the release, because after 1 year things are getting changed. When we started using WhatsApp, but what was the communication point before the evolution of WhatsApp? We did communicate, right? The point is what fit right for the time. And currently, modern applications like the agile technologies, or rather the agile approach, is going to be like more fit for the current trend, because applications are shipped into productions more faster. I think now I can see I hope that I answered your question. I will be able to see the question here, maybe. Yeah.
Yes, sir. We have another question. Is there a data breach reported in blockchain technology?
Yes. So smart contract have issues, and not all smart contract, right? By smart contract means like in blockchain technologies, there are um, you create like smart contracts to sign and authorize a transaction, and there are issues there as well. It's an interesting experimental area. There are a lot of research happens there. I know some people actually doing like focused research on blockchain technologies and the security of it. And yeah, I mean, it's not immune to security breach. They are also having security issues.
Okay, sir. We have one more question. Many Android apps require SMS access to get installed. And if we don't allow access, the app doesn't work. So, do we have a solution for that or any other alternative?
The reason why they are using this the SMS based application or SMS based authentication is to make sure that you are not a bot. You're not an automated programs trying to sign up in applications and create tons of millions of requests. And that happens in apps to apps. The way you can actually see like 10 million downloads on an app or 10 million active users on the apps, not necessarily need to be the actual users. It can be automated using bots. There are services to do that. So that's one of the reasons why they're using like SMS based authentications or SMS based OTP. But for an app using or an app asking for a permission to read your SMS or write your SMS is a bit concerning. So we probably need to know why an application requires it and have a judgmental mind there, because some cases the application have legitimate reasons why they need to access the SMS app. We probably can allow that. But if it's a small game and for some reason it's accessing your message permissions, there is something suspicious. And not just in Android or iPhone app stores, there are definitely serious concerns in like the legitimacy of an applications. I mean, everyone is aware about TikTok got banned in last few days. There was a research actually happened on that, published about what privacy issues they're actually going to be, that's going to be violating, right? And it's an interesting. So you can actually read through that research papers, and they will tell you like they have permissions that's insane, because we wouldn't know that whether an application requires such kind of a permission. So the legitimacy is a bit tricky unless you download and for an Android app, just download that APK file, unpack those package, read that code, and see why they're using it. It's a good way to understand why an application needs it, but it's not everyone's capability. But I would say like have a bit of judgmental mind an application whether it is required or not, and just allow what's required. And sometimes the application just works if it is if these are like optional permissions. But if it's a mandatory permissions, especially on um, browser histories or SMS or payment informations or wallet informations, just have a double check there. Not everything what we see is legitimate.
We have some restrictions to time, so we'll take our last question now. What are the common security vulnerabilities in web applications?
So as I mentioned here, so OWASP top 10 is providing you like a top 10 vulnerability list. So you can take a note of this slide. OWASP.org, you will see a top 10 vulnerabilities. Now these are updated over 3 years. Every 3 years they will come up because trends are changing, the new attack surfaces are happening. So 3 years they will update this standard. This is a good to start with. Of course, these are not the only vulnerabilities exist. They are only the top 10 according to the trend. And the way they are ranking it is based on how frequently the attack happened and what's the impact of it, and what's the affected component of it. And there are several criterias on which they are ranking it. Meaning the top one, if the application has a vulnerability that is listed as top one, that's going to be like complete compromise of the website and the servers. So it's the ranking is happened on that. So to begin with, it's good to start with OWASP top 10, and then you can go with other standards that's more elaborate. Let's say, for example, WASC, or Web Application Security Consortium. They can kind of cover the entire list, not just top 10. So, but maybe a little bit overwhelming to start with. So I would suggest to start with the WAS top 10.
Okay, sir. Thank you. We've now come to the end of our webinar. I'd like to extend my gratitude to all of you who participated, to Wimla College and all of our staff for their unending support. And a very big thank you to Mr. Sanoop for making the time to talk to us. And thank you all for your support and cooperation. I hope you have a great day ahead. Thank you.
Thanks, everyone.